20 years ago this week, astronomers witnessed one of the brightest stellar explosions in more than 400 years, a supernova that blazed with a power of 100 million suns. Next on Book TV, astrophysicist Neil deGrasse Tyson. His new collection is Death by Black Hole and Other Cosmic Quandaries. This talk from the Hayden Planetarium at the American Museum of Natural History in New York City is about an hour 45 minutes.
Good evening. It's quite a wonderful showing for this night. So you might be wondering, who is this strange man standing in front of you? And I mean, I look exactly like Neil, and so I might just introduce myself as Neil deGrasse Tyson. No, actually, I am here to introduce him. He's an old friend of mine, and I'm very happy to have this pleasure and honor to introduce this great man who is about to show up here. And my name is Ben Oppenheimer. I'm one of the astrophysicists here at the museum. But I thought about, well, how do you introduce a man like this? Everybody has some notion of who he is. Otherwise, we wouldn't have this showing like this in the audience. So I thought I could go through all the ridiculous things he's done in his life, like going to a substandard school up in Boston, up in Cambridge, something called Harvard, I think it was. I don't know these things. But he did decide ultimately to go to Columbia for his PhD, which was a magnificent decision. And in fact, that's where I met him 17 years ago when I was an undergraduate, and he was a graduate student. And I thought, wow, this guy is really dynamic, but he's kind of a slacker. And I wonder what he's going to end up doing. And we used to joke around a lot. It invariably led to my being punched in the stomach at some point. And if I run out of here later, it's because I'm avoiding another one of those punches, so please excuse me. But then over the years, I went off to graduate school in California. We lost touch for a while, got back in touch around 1999. And I heard that he was putting together this magnificent new planetarium, rebuilding the Hayden, which I had grown up going to, of course. And he showed me around before it opened, and there was this certain glee in his eye, just utter pleasure and excitement of walking around, seeing these new exhibits, explaining some very complicated ideas in modern astrophysics in a way that hadn't been done before. And I could tell his passion was there. This was no slacker at all, and you can go and look up all of his various accomplishments. There are many, but I'll tell you this, I know of nobody, any colleague or any even acquaintance who has a dedication and interest and passion for educating the public about what we do in astrophysics other than Neil Tyson. And he's got a way of saying things that I hope you enjoy this evening. So without further ado, I will introduce my great friend and colleague, Neil deGrasse Tyson.
Thank you all for coming out this evening. I'm just told that there's a foot of snow that just fell, so we're stuck here all night. Most of the time that I'm called upon to speak to the press, it's because there's some cosmic thing that happened. The universe flinched. And here at the American Museum of Natural History, we're not far from the major news centers of the nation. ABC, CBS, NBC, CNN is now just down the block. And so I'm actually a little uncomfortable being in the media for something that is a fully just sort of marketed thing, all right? I'm in the media now because there are marketing people that put my face in front of the camera to sell this book. This book, for those on the TV screen. If you might not have known, we are being taped for later air on C-SPAN this evening. So whatever you say can and will be held against you. I guess my point is, I would say 85% of the time I get approached by the press, it is because I didn't twist their arm. They wanted a comment on something that happened in the universe. And that level of public curiosity and appetite for the cosmos, I don't take lightly, neither do any of my colleagues. We see it as a genuine measure of the public's fascination and appreciation for all we do in the professional astrophysics community. And in case you want to know how many of us there are, there's about 6,500, 6,500 astrophysicists in the world. And if you remember your population numbers for the world, that number is about 6.5 billion. So you divide those two numbers, you get 1 in a million. So here's the catch. If you're ever in the company of an astrophysicist, that's the time to ask your questions. Because you never know when the next time will be where you'll be around another astrophysicist, okay? But it's not that many people who are responsible for bringing all these riches of the universe to you. And we are tickled to death every time the public shows interest. If not for the Hubble telescope, for discovery of a black hole in the center of the galaxy, right on down to the discoveries of the space program. So I want to publicly thank all of you and the rest of what makes up the general public for your support for what we do over all these years and what I expect to continue into the future. I want to make sure there's plenty of time for Q&A at the end. It's my favorite part of a program. And I'm not going to read from the book, because you can just buy the book and read the book. You don't need me to do that. So what I want to do is first tell you about it, and then sort of pluck subjects from it, and then reflect on those subjects. And I'll do that for most of the hour, and then we'll break and take Q&A. That's the layout for the evening. The book is called Death by Black Hole. And of course, I was told that C-SPAN has that one camera, and so you put this here, then it's just always in view, of the camera. I learned that from Andy Rooney some years back. He just took his book and just put it there and went and had a cup of coffee, and they had to keep showing it, I started writing for Natural History magazine as a columnist in 1995. The then editor had heard me on the radio and felt that they needed some contributions from the universe to bookend the magazine with the contribution that they were getting monthly from Stephen Jay Gould. And so I said, sure, sounds like fun. And so I began in January 1995, not knowing that every month writing an essay, at least for me, would be like giving birth. Now the women are saying, you have no clue what giving birth is. Okay, I confess, I have no clue about giving birth. However, each of these essays is sort of the sum, each essay that forms a chapter in this book. 12 years, hand-picked essays that have appeared in Natural History magazine, selected and culled and organized for this volume. Each month that I wrote an essay, it was the sum of what I knew in astrophysics, all that I knew as an educator, and all that I could bring together to make it real. And to pump that out each month, it was like my flesh was getting hewn from my body and put down onto the page. And I felt like after each month I had to regrow part of my body cells. Okay, that's why all I can think of is like it was giving birth. And so no, it's not easy to do that, it's hard to do that, but it is one of the greatest pleasures of my life, because I get to think about what words to use, what phrases, what words work together, either poetically, scientifically, rhythmically. And so it's my hope that you could pick up this book, open to any page, and land on a paragraph in that page, and you'll feel good reading that paragraph. Okay? That's my goal. Now, whether I achieve that goal, I don't know, but that's the goal. And so these chapters are some of what I feel were my best, as well as chapters that I didn't necessarily feel were my best, but were highly requested on my website and by other means of communication, highly requested by the public. So we're organized in sections, and I'm just going to pluck something from each section. First section, the nature of knowledge. Later on, there's a part, my favorite section is when the universe turns bad. All the ways the cosmos wants to kill us. And in there is the title chapter, Death by Black Hole. But there's also a chapter on killer asteroids, and a full discussion of one that's actually headed our way. If we have time, I'll get to that. Just remind me if we can fit that in. But just if there's time, I don't want, just if it fits in the session that we have together, remind me to tell you about the asteroid that will render the entire west coast of the United States unlivable. So let me lead off. There's a section here called The Nature of Knowledge. And there's an essay there that was smooth, right? That worked. That one worked. Hardly ever works, but it worked now. We'll do anything for C-SPAN here. There's a chapter called Coming to Your Senses. And I want to just sort of share with you where I'm trying to go there. We all know the human body has senses. How many? 5. Some people claim they have a 6th sense. We'll get to that in a moment. But the 5 we know and love, sight, hearing, touch, taste, and smell. Thank you. Now, a couple of these are not very useful when you're studying the universe, like taste. Your tongue doesn't reach the cosmos. So the tongue is not very useful. Neither is your sense of touch. But sight is certainly very useful. No doubt about it. And excuse me, I'm nursing a chest cold from a few weeks ago, so forgive me. We got our 5 senses. And then there's some people who say they have a 6th sense. They can know things that your 5 senses can't. And you say, well, what might that be? They can maybe feel like they know the future, or they know when someone's looking at them, or they feel it somehow. Turns out, anytime you bring that person into a controlled laboratory, those talents just go away. They just don't exist. They're missing in the laboratory. So either it is an actual talent that just somehow hates laboratories, or there's sort of a delusional thing where you think you have the power, but in fact you don't, and you're remembering the hits and not the misses. Like you pick up the phone, you say, Grandma, I knew that was going to be you. Okay? Well, if it wasn't her, you wouldn't say, oh, I thought this was going to be my grandma. You just don't even say that, because you kind of look bad. And so you forget the misses, you remember the hits, and there's this self-selection going. Psychologists have known about this forever. We dupe ourselves into thinking we are more powerful and more brilliant and deeper and more insightful than we actually are. Maybe it's an ego-preserving feature of what it is to be human. But by the time our session together is over, I hope to disavow you of those great feelings you might have of ourselves as a species. So, it turns out, in science, we have dozens of senses. There's plenty of things you might want to know about, but you can't because you're limited to your 5 senses. For example, right now you have no clue and no way to measure without a device what is the level of the magnetic field in this room. No clue. If you could measure magnetic field, you could think of that as another sense. Measure the magnetic fields around you. We have no idea. We are not equipped for that. Neither can we measure, for example, the presence of ionizing radiation. Well, you would eventually know this because, like, your limbs would fall off and you say, hey, something happened. Okay? You'd be sterile, although that'd take a little longer to figure out. We have no capacity to measure this. Other things, other things. You don't know, there's some obscure things like polarization. You can't detect the polarization of light, and that light vibrates in 2 different directions. And you can polarize it so it only vibrates in one direction. You can devise glasses that can polarize light, but you still wouldn't know the difference. You don't know. It's a big deal in astrophysics, whether light is polarized or not. That tells us where light is coming from and what its points of origins are. But another sort of everyday thing you just can't figure out, one of them is you can't detect low-level earth tremors. Why? Because you have, like, shock absorbers in your knees. And so your knees sort of get rid of it. You have filters against it, but you put up a seismograph, there it is. There it is. So I can go on and on and on and on and on. Perhaps the most important sense we don't have is the ability to see outside of the spectrum of visible light. You know visible light, Roy G. Biv. Red, orange, yellow, green, blue, indigo, indigo violet. It's a BIV there, B-I-V. Now, where'd the indigo come from? Isaac Newton, who first labeled the colors of the spectrum, had this mystical fascination with the numeral 7, the number 7. And so when he went to label the colors of the spectrum and got 6, he said, we need 7 somewhere in there. So there's indigo. You got it, we're stuck with indigo. Now, if you have enough precision to put in indigo, the 10 other colors we could have given you in this full continuum of this spectral light. Any color-sensitive people could rattle off 30 colors in there. But no, we got 7, and Roy G. Biv was born. Okay. If you go beyond the V, beyond V, you get what? Ultraviolet. We have no way to detect ultraviolet. Actually, that's not completely true. You can detect it in a time delay sense. Okay? So, depending on what shade of skin color you have, you go out to the beach and lay under the sun. If you are not protected, you're laying there, that's fine, and then how many hours later you look like a lobster? Okay, so there's a delay there. It's the ultraviolet that made you look like a lobster, but you didn't know it at the time. At the time. So by the time you figured it out, it was too late. Let's go to the other side of red. You get infrared. Can't see that either. We do have infrared sensors. We sense infrared in the form of heat. That's what we call heat when we feel infrared. But beyond infrared, there's microwaves. We have no microwave detectors. Well, now we do because we all carry around cell phones. These are microwave detectors. But if our eyes were sensitive to microwaves, tune in the microwaves, all your cell phones would be ablaze with light. Okay? We'd all be walking down the street, you know, and you'd know who had a phone call and who didn't. Okay? If we had microwave detectors, the microwave towers would be ablaze in broad daylight and in the middle of the night. We have no such detectors. Radio waves, we can't detect radio waves. X-rays, gamma rays. This is the full sweep of the electromagnetic spectrum. And in astrophysics, we have telescopes and detectors in each one of these bands, far beyond what your naked eye can detect. And so every day, every night of every day, the astrophysicist is invoking a full suite of senses that brings us that much closer to the universe. Because if you only observe the night sky with a visible light telescope, expressions of our own eyeballs, you'd be missing what black holes are doing in their environment. They're dining, they're flaying stars, the outer gas layers of stars as it descends, spirals and descends down to this abyss. It radiates ultraviolet and X-rays. So the first X-ray telescope, the first first thing it discovered in the universe was a black hole candidate. SCO X1, Scorpius X1. Then there was another one in the constellation Cygnus, called Cygnus X1. These were sources of X-rays we were previously blind to. Turns out, black hole, right there. Black hole. So you can't claim to know the universe unless you look in as many different ways and invoke as many different senses as you possibly can. Now, there's a point to all of this. The point is, until about the turn of the century, not our century, but the 1800s to the 1900s, until then, it was possible to do an experiment and say to yourself, that makes sense, or that doesn't make sense. And you had a good chance of being accurate in your assessment. Come the 20th century, where telescopes started getting seriously big, where atom smashers started breaking apart atoms, probing nature on levels and on scales never previously accessible to our senses. Now, what does it mean for something to make sense? For something to make sense, what that means is, if I take this bottle of water and I let go of it, what will happen to it? It will fall. In fact, so linked is my act of letting go to the fact of this falling in our minds that all you have to do is say to me, drop it. And that means let go. But suppose you lived in a world where 30% of the time, when you let go, this went and floated to the ceiling. 30% of the time. And so only 70% of the time it fell. Well, then common sense would mean something different under those conditions. What was common is 30% of the time the thing floats up. So the word drop wouldn't even exist. Oh. Someone gasped over in the corner here. It would be, let go and let's see what happens. You know, people be taking bets. You know, people bet on all kinds of things. So what happens is we break the atom, get inside, get into the nucleus, and a whole new world of physics opens up to us. The world of quantum mechanics, where the laws are different. Edwin Hubble discovers that our galaxy is not alone among galaxies in the universe. A great discovery of the 1920s going on simultaneously while quantum mechanics was being discovered, the science of the small. And not only that, he discovers that the galaxies are hurtling away from each other. He discovers the expanding universe. A few years later, the Big Bang theory of the universe advances, with not much data, but that we're expanding at the time. You turn the clock back, you find that the whole universe, sometime in the past, all occupied the same volume at the same time. And you say, that doesn't make sense. How could the whole universe fit on the head of a pin? That doesn't make sense. And then you realize the universe doesn't care about your senses because we're probing it beyond the range that your senses were formulated. Our senses emerge from being born an ordinary human being in this world, breathing air, walking in 1 G's worth of gravity. That is our life. And so in modern science, we no longer require that a successful idea makes sense. And I think that's created quite a bit of confusion when a scientist says, oh, well, the whole universe was this, and a particle pops out of existence here and shows up there, and there's 11 dimensions, and this, and you hear this say, what's he smoking? You know? You wonder what's going on with the scientists today. And the fact is, our regime is no longer grounded in the limitations of the 5 senses we carry with us. And so the lesson there, and what comes across in that chapter is my goal, is that before you celebrate the brilliance of our 5 senses, think about what it is you're not seeing about the universe, and then ask yourself, what do you need to know about that in order to claim that you know the universe to begin with? And that's coming to your senses. Another one, the knowledge of nature. I'll talk about the vagabonds of the solar system. In there's like Pluto shows up, but I'm done with Pluto, okay? So let's leave Pluto alone for a night. I think it's got to get over having been Plutoed. That was the word of the year. Did you see that? To be Plutoed? Plutoed. So was Pluto Plutoed? Or was Pluto something else which had to happen and then everything else is Plutoed thereafter? We got to get top linguist on this, all right? Get a full report on that in the morning. So we'll slip by that one. I'm okay. You okay with that? I'm okay with that. I got one here, Goldilocks. Here we are in section 4, the meaning of life, the challenges and triumphs of knowing how we got here. We've got a chapter called Goldilocks and the 3 planets. You remember Goldilocks. We all know Goldilocks. Yeah, we all know Goldilocks. You know Goldilocks. Goldilocks. Now, here's my problem with the Goldilocks story, okay? I got a problem. Because if I were the Bears and I found Goldilocks in the house, I'd just eat Goldilocks, okay? That's what would happen, right? That'd be the end of the story, and the lesson is don't go busting into other people's houses, okay? You want a lesson, there's a lesson, all right? But they want their lesson to be a little more nuanced. So, one porridge is too hot, the other's too cold, one is just right. Well, in the solar system, you can be a distance from the host star that might be too close for water to be sustained as a liquid. If so, all the water on your planet will evaporate. Not available to you to make life. Because life as we know it requires liquid water. So now if you can go a little farther away, whatever water you might have, you're too far from the sun, the intensity of the sun's energy is too low, the water freezes. Once again, not available for your circulatory system. And so you imagine that beyond a certain distance, you would not find planets with water, nor then planets with life. So there'd be this comfortable Goldilocks zone, the habitable zone, where you'd find liquid water prevalent on the surface of a planet. Fine. Fine. Turns out you can go outside the zone and find water, but I'll get to that later. But right now, let's just consider that scenario. Now, turns out other things affect this, like greenhouse gases that trap heat and air pressure, where if the pressure's too low, you can't have liquid water. The water just goes straight from ice to gas. You've seen this before. It happens with dry ice. Do they still have the ice cream man in the park, and he opens up the thing and there's dry ice and it's frozen carbon dioxide? You've never seen liquid carbon dioxide because the air pressure on Earth is too low for it to ever reach a liquid. It goes straight from solid to gas. We have a word for that. It's called sublime. I kind of like that word, sublime, for such an odd chemical phenomenon. And so fine. So we're here on Earth and say, we're fine. We've got room temperature. I'm good with that. And then you look a little to the left, you get Venus, our sister planet. It's about the same size as we are, about the same mass as we are. A lot of the same structural features that we have. And it's just a little closer to the sun than we are. If we are 1 unit of distance from the sun, Venus is 0.7. So Venus is 70% of the way to us from the sun. So you say, okay, Venus, are you just like Earth? No. Venus, its atmosphere is nearly 100 times as thick as our atmosphere. That's bad enough, because you'll just get crushed. But you'd be lucky if that's all that happened to you. Because the temperature on Venus, it having a carbon dioxide atmosphere, it has a runaway greenhouse effect. It is 900 degrees Fahrenheit on the surface of Venus. 900 degrees. And I did the math. You could take a 16-inch pizza, put it out on the windowsill, and it will cook in 9 seconds. You would have been vaporized in the process, but you'll have a cooked pizza that's just right in 9 seconds, okay? Now, of course, Venus is the goddess of love and beauty, and it's 900 degrees. They didn't know that when they named the planet. Now let's go a little to the right. A little bit farther from the sun than we are. We get planet Mars. Mars has riverbeds that meander, floodplains, river deltas, lake beds, but not a single drop of water at all. But these features were made by water. We are 99% confident of that assertion. That's what water does when it flows in abundance. It makes rivers and lakes and valleys and river deltas. You could do a comparative geography of Earth features and Mars features, and one for one, you nail all of them. Where'd the water go? Nobody knows. We think it sunk down below the surface, froze there in a kind of permafrost situation, but there's none on the surface. Some knobs got turned on Venus and on Mars to turn them into what we would consider completely inhospitable environments. Venus is 900 degrees Fahrenheit. Mars is 250 degrees below zero. Bone dry. Mars, it's right there. It's right there. Do you know Mars, among all the planets, is the most hospitable place there is after Earth? Yet it'll kill you post-haste. So the lesson there for me is we know Mars once had water and it does not. Why not? Let's find out why. Because if we find out which knob had turned in the ecosystem of Mars, I want to know if we're turning that same knob here on Earth. We don't know that. You got people say, why are we studying the universe? We don't need, what if we worry about Earth problems here? And I'm thinking, well, how about that asteroid coming in? You're not looking up for that one. You worried about the budget and Congress and this? We got an asteroid coming. We got a planet that has a runaway greenhouse, a planet that used to have water and does not. Excuse me. Where do you think answers are going to come from? We're not an island. They come from the sky. Thank you. Answers are going to come from the sky. We're not some island. We are a participant in the cosmos. Vulnerable to cosmic phenomena. Not only that, there's cosmic phenomena that would give us insight into who and what we are. And if we don't have that urge, you just move back into the cave. Because that's where we'd all be if we didn't have some fraction of us out there trying to push that frontier. It wouldn't have to be a cosmic frontier, just any frontier. Well, I wonder what's on the other side of the cliff. That person doesn't come back, so that's fine. What's on the other side of the valley? It's a cliff. I meant to say mountain there. I'm sorry. I didn't mean the other side of the cliff. Let's start that again. So they said, what's on the other side of the mountain? And so they go and find out, and they bring back fruits or riches or whatever. Whatever. That's what exploration is. That's what it is to be human. That's why we have a space program. That's why we have the luxury of having a space program. So I don't know, the universe, I see that's the ticket right there. That's where our insights will come about where we fit in this universe. I'm going to go on to our radio bubble. It's part of the section on the meaning of life. A radio bubble, you might have not heard that phrase before, I don't know. A radio bubble. A radio bubble, you might say, if there are aliens out there that are intelligent, how would you tell them that you're here? Do you send a spaceship? Our fastest spaceships ever launched would take 75,000, 50,000 years to reach the nearest star. That's slow. And there's a rule in science. If you do an experiment, you want to be alive when the experiment is done. They don't tell you that in graduate school, but you figure that out empirically, okay? So, sending a probe to another planet, I don't think so. Not unless we develop warp drives or something, okay? And that could happen, but I don't think anytime soon, or anytime that we should be banking on. So, what do you do? Well, you can send light. How about radio waves? That's light, a form of light, radio waves. We have big radio telescopes, just reverse them, send us a signal out the other way. It will travel at the speed of light, 186,000 miles per second. Still takes a while. There's nothing close out there, nothing. The nearest star to the sun is 4 years away, traveling at the speed of light. So it still takes a while, but you can outlive that one, all right? So you do this, and you say, well, wait a minute, maybe we have a head start on this plan. Let's look back in time. How long have we been radio loud? How long have we been producing radio signals on Earth, some of which will have leaked away from Earth? You just go back in time. Turns out TV waves, the frequency that we use to communicate with television, those go straight. If they don't hit you, they're gone. They leave the atmosphere. That's why you don't, like in the old days, remember when TVs had antennas? Remember that? Yeah, you're all 20 and under, I know, right? There was a day long ago where you had to get out of your sofa to change the channel of the television set. And while you did that, you had to adjust the antenna until it was just right, but then you'd be in the way of the screen. Then you'd let go, and then the image would go bad again. So everyone would then tell you to stand there holding the antenna. This was many moons ago. People used to live this way. It's true. I'm making it. I'm just thinking, people they could sit in the couch, honey, where's the remote? You know, and like spend 10 minutes looking for the remote rather than just going up to the TV to change the channel. Anyhow, back when TV was broadcast, which it still is, but A lot of people get it via cable today. TV waves would go straight out. And so too would shortwave radio would go, well, it depends on which wavelength you use. Some would reflect off the ionosphere of the Earth and stay sort of trapped. Others would escape. But if you take the inventory of what these programs were, you can say, hey, we have this growing sphere of influence in the galaxy, beginning with our earliest broadcast. They've been going now for 70 years. So, in fact, we are in the middle of our own radio bubble that has a radius of 70 light years. It's a radius that has washed over all the stars that fill that volume. Hundreds of stars. And so we've already announced ourselves to aliens, if they're there and want to listen. So the earliest of these programs, it would be, so the aliens would listen in, right? They get the feeble signal, but they're smart aliens, so they can figure it out, recode the carrier signal to the main thing, and get the image, and there's howdy doody, okay? And then they see, well, this is an interesting species. Let me figure out how the male and the female interact with one another. And they learn that from early episodes of I Love Lucy. Yes, these are benchmark ways that men and women interact. And then as the radio wave continues to wash over, then they have episodes of Gomer Pyle. You know, and you think about this, this is our first introduction to the aliens. This is kind of scary. Now, there's some programs that they would never get, programs that have only ever been broadcast over cable, like MTV's Beavis and Butthead, okay? So there's certain things that are good that's not the first thing the aliens get. So some programming is forever hidden in the electrons of your coaxial cable. So you look at this and you say, what will they think of us? You know, and then they get broadcast that there was like atomic bomb and 100,000 war, and I am certain that these aliens who are in desperate search themselves for intelligent life in the universe, they will conclude that Earth does not contain intelligent life. And pass us by. How am I doing on time here? Are we okay? I got a few more things to talk. Are we okay? You cool? Everybody got like be somewhere after this? I just want to make sure that we're okay. I don't want to mess up your plans for later. Where are we going? So, when the universe turns bad. Ooh. Well, that contains the title chapter. Death by black hole. Now, to get in trouble with a black hole, you got to go out and find them. There aren't that many of them in the galaxy. So you're looking for trouble if you die for having fallen into a black hole. I'm just letting you know that now. But if I had my choice, that's how I would die. Because it is so cool. All right? No, you can say, well, Dr. Tyson, would you like to sort of die in this hospital bed, in this hospice? That's what they call them, hospices, right? I said, no, launch me to the black hole right over there in the gamma sector, all right? That's how I want to do it. So here's what happens. You stand up here on Earth, and okay, I'm 6-something, and my feet are closer to the center of the Earth than the top of my head is. You can do the math, and you can calculate that the force of gravity between Earth and you is stronger at your feet than it is at your head, because your feet are closer to the center of the Earth. It's simple Newtonian gravity. But you don't feel that difference. And don't blame being lightheaded on this fact, right? If that's not what made, whatever you, it's not this. So here you are, and you don't notice it because your body overcomes it. It's barely measurable. And why is it barely measurable? Because you are tiny. I am tiny compared with the size of the Earth. The Earth is 8,000 miles in diameter. Well, going to the center, 4,000 miles to the center, and I'm 6 feet standing on top of it. That's nothing. A black hole, however, because it's so small, you can get much closer to it compared with your height. And so what happens is you descend to the abyss, and your feet lead. So imagine a feet-first dive to the black hole. And so you start getting pulled, and you begin to stretch. And that kind of feels good. You know, we all like, it's what you do when you wake up in the morning. You stretch. People pay top dollar to stretch. What do you think all the yoga people do? They're stretching, okay? And it feels good until you realize it's not stopping. And you say, okay, I'm not having fun anymore. And, by the way, this difference in gravity is called the tidal force. It's the same kind of forcing that creates the tides on Earth, why the water stretches across Earth's surface. So as you get pulled, you begin to feel it. And there is a point where the difference in gravity between your head and your toe becomes greater than the molecular bonds of your flesh. And at that moment, your body snaps into two pieces. And then those two pieces continue to descend, and they feel this difference in gravity. And then they snap into two pieces each. Now we went from 1 to 2, we're now up to 4. Continue. We got someone in the front row who's plugging his ears. He didn't want to hear about getting snapped into two pieces. And this continues, 1 to 2 to 4 to 8 to 16 to 32. You keep this up, you're not much of anything after a short while. You're just this stream of particles descending down. Now, it turns out that's not even the worst thing to happen to you. It gets worse, because in a black hole, the vicinity around of this fabric of space and time, in the vicinity of a black hole, funnels you. It narrows as it comes near the black hole. This is what we learned from Einstein's general relativity. It describes the shape of space in the presence of gravity. And you do up the math, you find out that at a black hole, space funnels down to the point. So as you descend the black hole, you are not only stretched, you are extruded through the fabric of, and you move through the fabric of space and time like toothpaste through a tube. And we have a word for this. It's called spaghettification. That's cool, that there's a word for dying while falling into a black hole. Spaghettification. I don't know if it's fusilli spaghetti, I don't know, whatever, but it's, you know, number 2 spaghetti, number 8, whatever that is. Any pasta aficionados here? Angel hair. Angel hair pasta. That's the thinnest of them, if I remember correctly. Because they measured the thickness of angel's hair to determine this. So you want to avoid black holes. And by the way, they tear up the environment. We got a big one in the center of the Milky Way galaxy, although it's not the biggest in the neighborhood. There's the Andromeda galaxy, our nearest big neighbor. It's got one that dwarfs our black hole, okay? And some astrophysicists have, like, black hole envy. You know, it's like, well, how come ours isn't as big as that? Because there's, like, cool stuff happening in the middle of the Andromeda galaxy because it's got a bigger black hole than it. We got some cool stuff, but theirs is cooler. And what we learned is that most galaxies, indeed, have black holes in their centers. In their centers. And the properties of so many galaxies, previously imagined to be distinct and separate, and classified as distinct objects, turns out it's just a matter of what angle we were viewing the turbulence created by the black hole in the center. So there's been a tremendous coming together of galactic information just over the past 10 or 15 years, simply because you're looking at a galaxy from a different way. And so black holes, you really simply just want to avoid them. I got a chapter in here which I think is my a section in here which I think is my favorite. It's when science meets culture. And in fact, if you're a little science phobic, which is probably not true if you even knew how to get into this museum and come to this room, but maybe you were dragged here by a friend. Raise your hand if you were dragged here by a friend tonight. We've got somebody in the back row, another one here. Brave of you, sir, to agree on your, you know, on your Tuesday night to come here. Thank you for coming. That section is an exploration of what happens when science meets culture. And I want to highlight a couple of items in it. I've got Fear of numbers. This one is kind of fun. You look around, you go in an elevator. This is the first indication that we are number phobic, okay? So you got the numbers, and then you get to the lobby. So you count them down, and it's not a 1, but it's an L. That's the lobby. But then there are always floors below the lobby. And then there's like LL, and B, and then BB, and then SB. And I'm thinking, what are you doing here? Just call it 0, -1, -2, negative. No, sirree. No negatives in this culture. Any accountants out there? No negatives on your balance sheet. You put your negative numbers in parentheses. Are you afraid of your negatives? Raise your hand. If you're an accountant here, raise your hand. Accountant, right there. Why do you, what's with you and the negative numbers, sir? Please, I gotta know. He doesn't know either. He's like, you get back to me on this one, okay? It's in parentheses. I was in a hotel in Geneva, Switzerland. They had negative numbers in their hotel. It went to 0, -1, -2, -3. And then I realized, of course, Switzerland, that's where the world's largest particle accelerator is located. People there are not afraid of numbers, so they can put negative numbers in their hotels. Another thing, take a walk up and down Broadway right here in Manhattan, in New York City, and go poke your head into each elevator bank. And you will find out that 75% of them, I did this experiment, do not have a number 13. Check it. Have you seen this? Look next time. And I'm thinking, this is not 21st century America. I'm going to go next time. I'm going to go on. I'm going to get a Sharpie and cross out the number 14 and put 13 next to it. I'm going to say, who are you fooling? That's the 13th floor. So you have people afraid of the number 13. If people are afraid of numbers, what hope do we have in this world? This is scary. Just afraid of a number. You know about the lottery? The state lottery, okay? It's widely said that that's a tax on the poor because people with lower incomes spend a disproportionately higher fraction of that income on the lottery. And if you look at the data on the lottery, your chance of winning 1 in 5 million or something, and I'm thinking to myself, no, it's not a tax on the poor. The lottery's a tax on everyone who never did well in mathematics in school. That's what it's a tax on. And you don't have to do that well in math to figure out that's not what to do with your money. Man, gets me angry. I gotta calm down. Wait, let me get a drink here. Hold on. All right, where was I? Let me add them. Okay, I got another one. One of my most highly requested essays. It's called Hollywood Nights. This one, I'm going to apologize in advance. Yes, on occasion, I'm one of those, if you bring me to the movie theater, I'm going to say, that's the wrong sky that they just put. The moon, that's the wrong moon. And I will be annoying as I sit next to you, but only on selected films. If the film has no pretense of getting any facts straight at all, then I don't even give it the time. I might even still enjoy the movie, but I'm not going to worry about it. But there's some films that had no excuse. At the top of that list is Titanic. We know what day it sank, what month it sank, what year it sank, what longitude, what latitude. We know everything about that night. So why is it then that Kate Winslet, after the ship sank, there she is on that wooden plank, okay? By the way, why didn't Leonardo DiCaprio try to climb on there with her? Why, what? Why not? At least experiment. He just clings on, okay, I'll just die here. I'm fine. I'm okay with that. It's like, what? Or find another plank? There's got to be some other floating stuff out there. Where was I? That was Kate Winslet. So there she is, and she's whistling in delirium, and she's looking straight up. There is only one sky she should have seen. And the sky that the camera showed you was the wrong sky. Not only that, the left side of that sky was a mirror reflection of the right side of the sky. It was not only wrong, it was lazy. And here's a film that was widely advertised as having they sent a submersible, Jim Cameron sent a submersible down to the Titanic and looked at the wall sconces and the china patterns and all the designs of the staterooms and got every rivet, every design perfect on his ship for his movie. Now, you can't double check any of that because you don't have a submersible. But for $50, you can buy a planetarium program to tell you what the sky looked like the night the Titanic sank. So I was pissed. So I wrote a letter. I rushed back to my office, got my finest of letterhead. I got letterhead that's got all 5 color letter, astrophysicist, I got everything on that letter. The director, Frederick P. Rose, director of that, I got all that. And I wrote the letter. No reply. I said, I tried, I did due diligence there. A couple of years later, I bump into Jim Cameron in Washington. Actually, not this time. I bumped him in Pasadena, California. There was a NASA meeting out there. In fact, he was very active with NASA. And he's an explorer. He's a genuine explorer on top of his other formidable talents as a movie producer and director. So he's there, and I said, I sent you a letter a couple of years ago. No, it's Mr. Cameron. I sent you a letter a couple of years ago about this and the sky, and it wasn't right, and I was kind of, all right? And he said, well, actually, that happened in post-production, and he missed that one. So I was still angry. I don't know. I was not a good enough answer for me, but that was the answer. He missed that one. Fine. So 2 years after that, no, what are we up to? This happened now we're up to 2003, just a couple of years ago. He was honored by Wired magazine with a big party here at the Rose Center for Earth and Space. And just because, it's my place, I got invited to sort of hang out. And they invited me to dinner. There's 8 of us, he and some of his closest friends. And we're there, he's with his friends, the wine is pouring. I said, here's my big chance to do it again. Okay? No, I'm just being immature at this point. So I said, Jim, because now I can call him Jim. We're drinking wine, you call him Jim. So I said, Jim, a couple of years ago, I told you about the sky, and I'm still kind of wondering, why didn't you think, why, what? And so he said, let me think this one. Last I checked, Titanic has grossed about $1 billion worldwide. Imagine how much more it would have grossed if I had the sky correct. Can I make a bigger fool of myself in front of them? So then I just let that one go. I was done. Until 2 months later, I get a phone call from some guy, and he says, hi, I'm Johnny Jones. I forgot the guy's name, but yeah, Johnny, everybody who I forget is just Johnny Jones. So he calls and says, I'm working in post-production for a reissue with the director's cut of the Titanic. And Jim Cameron tells me you have a sky for me to use for the new footage. Yes! Now, he couldn't change all the skies, the ones that were already sort of built in, but the new footage had the new sky. So, it is possible. There is hope in the world. And while I make fun of Jim, and the fact is he's a man of high integrity with regard to what he produces and what he cares about. And so I just want to tip my hat to him in that episode. And for politely putting me in my place, without actually just telling me that I was what he really wanted to surely have told me. I got one more, and then we'll just go to Q&A. How's that? Are we okay? We okay? Is the temperature all right out there? Yeah, I'm okay up here, too. So I'm glad. I'm glad. The final section is it's called Science and God, When Ways of Knowing Collide. And that section contains my most highly downloaded essay ever, written relatively recently. It's called The Perimeter of Ignorance. And I want to share with you some of the themes of that essay before we go to Q&A. I wrote that essay at a time when the intelligent design movement was garnering headlines weekly. And the intelligent design movement, in case you had forgotten or never knew or weren't paying attention, but you're a newspaper reading crowd, so I'm sure you were all there. Intelligent design is the assertion that there are things about nature that are so intricate, so sort of brilliant in concept, that it just couldn't have, and so defying of the methods and tools of science to decode, that it must have had the hand of an intelligent designer. And intelligent in that reference refers to something vastly more intelligent than our feeble human minds. And so that's the premise. And so you go around, look through nature, oh, that's one of those. That's intelligently designed. That's an intelligent design. Now, it's hard to separate the invocation of the word intelligent in that sentence with a reference to somebody's God. So you have to ask, is this a religious movement, or is it a movement of some pure philosophy, untouched by religion? You have to ask that. And the courts ask that of the movement. And the famous court case in Dover, Pennsylvania, November, just last November, where the school district tried to bring intelligent design into the science classroom as a science plan, as part of the science curriculum. And the judge read the evidence for and against intelligent design and basically threw the court case out. They threw it out. Wrote a 135, 150-page statement about why science, to do science, you need data and evidence and discovery and this sort of thing. And intelligent design didn't fulfill that. So here was this debate going on. And I don't jump into debates unless I think I have something unique to contribute. If you got a lot of voices, I'm okay. Go, do it. Let me find something that needs voices, okay? That one didn't really need my voice. There were plenty of people arguing. But then I thought, wait a minute. It's missing something. I've got to address this. And you know what it's missing? Intelligent design, that's what you call it today. But as an idea, it's been around for thousands of years. In AD 150, Claudius Ptolemy, one of the architects of the geocentric universe, Earth in the middle. It happened to be a wrong model, but it was brilliantly wrong. And it forced people to think about what's going on in the motions of the objects of the night sky. When he looked up, he'd see the planets move. This is pre-Newton, of course. He'd see the planets move, and then they slow down, stop, and then go backwards. And then slow down, stop, and then continue forward again. Nobody understood this. This was like a mystery. So Ptolemy would look up, and he penned these words in the manuscript of his greatest work. He said, "When I trace at my pleasure the windings to and fro of the heavenly bodies," the planets in that case, "I no longer touch earth with my feet. I stand in the presence of Zeus himself and take my fill of ambrosia." Now that's beautiful. There he is basking in the majesty of his god, Zeus, almost in celebration of his ignorance. I don't know what this is, but surely somebody does. That's Zeus. And I'm here with him. So that's a form of intelligent design. He looks at something he can't figure out. His tools available to him do nothing for him. So he says Zeus did it. Let's move forward. I'm going to leave some people out, but they're more of the same examples. The essay has them all. Let me fast forward to Isaac Newton. We're now going forward 1,700 years, 1,600 years. Fast forward to Isaac Newton. Isaac Newton's my man. I think he's the smartest person to ever walk this earth. And I'm not alone in that assessment. Now, if you want to fight me on that, we can do that. I'll give you just one example, and then they'll just to sort of temper you if you're ready to go to fisticuffs, because like Einstein's your man, or Leonardo, or whomever. I'm going to set you straight, okay? Isaac Newton discovers, well, first he's got to put the indigo in there, or gets that out of the way. Then, all right, actually did that second, but he discovers the laws of motion and the laws of gravity. And someone comes up to him and says, Ike, I don't know if he went by Ike, but sounds better. Ike, why do planets orbit in the shape of ellipses and not some other shape? An ellipse is a kind of squashed circle. So he looks and he said, you know, because by the way, his equations of gravity give you ellipses. And so, but he said, well, you know, I don't know. I'll get back to you. So he goes back home to his home in Lincolnshire, which is out of way triple suburbs of London. Newton was avoiding the plague that was running through London, killing many, many people. He left London. Newton was smart, okay? He left London. People are dying. You leave, okay? First indication of how smart the man is. He left London, went to a home in Lincolnshire, goes back. I forgot how long this took, but it wasn't very long. It was, you counted in months, not in years. So he goes back, figures out why his planets go in ellipses, and he comes back and says, I figured out. Here's why. And his friend, who he corresponded with by mail, said, that's great. What did you have to do to figure this out? He said, oh, I had to invent integral and differential calculus, and that helped me solve this answer. We struggle with our calculus class, and Newton invents it on a dare just to get something else done. And he did this before he turned 26. I could go on. Here's a story shared to me. C-SPAN, how you doing? You got enough tape in the thing there? I got to get this other quick story on Newton. This is conveyed to me by Rich Gott, a friend and colleague at Princeton, where he'd spent some time in Cambridge and learned these sort of Newton stories. Apparently, over the River Cam, there's a Cam River, that's where you get Cambridge, Isaac Newton designed a bridge. It's not a big river, it's like a stream. It's called a river, but it's a stream. He designed a bridge made of wood that enables you to walk across the bridge, to walk across the river. This bridge had no screws or nails in it. It was just wood pieces assembled together into a stable bridge. Then at some point, 100 years later, people figure, well, maybe we should clean the bridge or polish it up. So they take apart the bridge. And they can't figure out how to put it back together. So they got nails in it now. Isaac Newton. Also, he's responsible for the ridges on coins. Where'd that come from? Well, he was so famous in his day, the government had to like reward him somehow, so they made him Chancellor of the Exchequer. So he tracked British currency, made sure there was no counterfeiters, and it was his idea to put ridges on coins. And that's why today we have ridges on our coins. You want to know why? You do? It's not really relevant to anything, but I did kind of lead you there, didn't I? Okay, so the ridges, it turns out, in the old days, coins used to be made of like precious metal, right? Not today, we know. But back then, the coin was silver or gold. So a coin comes into your possession, you say, nobody will notice. Let me just file off just a little bit of the edge and collect it in a little vessel. Nobody will notice. Then if I do this enough times, I'll have a pot of gold. Now, you think you're the only one thinking this, but everybody's thinking this. And so the coins just got smaller and smaller and smaller. And so he said, we got to do something about it. You put ridges on it. If the ridges are wiped away, you decline the coin. It takes a brilliant man to come up with something that simple. And so all of our coins, dime and up, have ridges, and no one wants to file copper off your penny, all right? There's a point where you just don't put in the ridges, all right? It's like, keep the penny, all right? Yeah, put the whole penny in the thing. No one's gonna hurt, no one's gonna miss it. So where was I? Back to intelligent design. So here's Newton. So I think I made it clear to you what I think of the man. So he solves his equations for gravity and says, okay, it's a two-body problem. So he figured out Earth-Moon and the orbit, figured out the sun and the Earth. He's got it. He figured it out. Figured out the sun and each of the planets. But then he realized that as Earth comes around the bend, and if Jupiter happens to be out there, that not only is the sun and Earth pulling on each other, Jupiter is tugging on Earth. Every time we come around the back stretch, Jupiter is tugging. And I come around, I gotta go a little further because Jupiter went further, and I come around, I get the tug again. And so he looked at this. We got the major gravity, and then we have these minor tugs. And he tried his best to figure this out. He said, this system is unstable. You keep this up, the orbits will get distorted out of recognition, and Earth would fly off into space. Yet somehow we're all still here. And somehow the orbits are pretty circular. So they're ellipses, but not bad ellipses. So something is keeping things stable. And for the first time in his entire record of the discovery of the laws of mechanics and the laws of gravity, in this tome, one of the greatest science books ever written, and it's called Principia. In that, for the first time, Isaac Newton says, God must step in and fix things. He didn't mention God talking about his formula F equals ma, his formula for motion. He didn't talk about God when he knew and figured out the motions of the planets and its universal law of gravity. God is nowhere to be found. He gets to a point where he can't answer the question, God is there. That's intelligent design. Something he couldn't figure out. There it is. He didn't say, maybe someone else smarter than I will figure this out one day. That's not what he said. And so, this concept of reaching the limits of your knowledge and then saying God is there is old. It's not new. It didn't first show up in Dover, Pennsylvania. And we're not talking about uneducated people here. We're talking about some of the most brilliant minds the world has ever produced. So now what happened? Let's fast forward. It took 130 years, but somebody was finally born who could solve that problem. Simon Pierre de Laplace, a brilliant French mathematician of the late 18th century. In the last 3 years of the 18th century, he produced a 5-volume tome called Céleste Mécanique, or Mécanique, Celestial Mechanics in English. But he's French, so that's what it was. So in there, he studies the stability of the solar system, invents a new, or develops, perfects a new branch of calculus called perturbation theory. And what he says is, okay, I can figure it out. Set up the equation this way. You've got the main force, and now you have these little tugs. Represent all these little tugs by this term in this equation. Now crank the equation. And when you do that, it turns out the little tugs don't amount to much. They all cancel out. And so that, in fact, the solar system is stable beyond Newton's projections for it. Napoleon, who's a contemporary of Laplace, summoned up this document. Napoleon, he wasn't just a little tyrant. He studied engineering and physics so that he would know where his cannonballs would drop. Okay? That's at least half the reason why he was successful. You go to his library, which I visited, it's a whole wall of just physics and engineering and what's the study of materials? Metallurgy and metallurgy. All on the wall. So he summons up Laplace. Said this is a brilliant piece of work. Napoleon was smart enough to have read this book, knew enough math to have read this book and gotten the main gist of it. He said, Laplace, this is a brilliant piece of work, but you make no mention of the architect of the system. And Laplace replied, "Sir, I had no need for that hypothesis." And so here you have a delay of 130 years of a problem that previously was ascribed to the handiwork of God, now was no longer an assumption. And it gets solved by somebody who's brilliant. And so what we've learned over all of these examples, and there are tons of them one can cite, is that intelligent design is a philosophy of ignorance. It is you get to something that you don't understand, and then you stop. You say God did it, and you no longer progress beyond that point. And you're going to wait around. Now, here's what's inexcusably hubristic about that comment. You're going to come to this point, and you're going to say, I can't solve this problem. Neither can anyone who will ever be born after me solve this problem. Therefore, it is intelligently designed. How dare you make that comment? Well, maybe it's true. But I don't want to put you in charge of the, like, Alzheimer's research or of the cancer prevention research. No, I'm going to put you somewhere else. Put you on the factory line or something. I'm going to get you out of that frontier lab because the discoveries are not coming from you. And so the issue in Dover should not have been kick ID out of the school system. No, it's weird. People have invoked it. You don't sweep that under the rug. It's a fascinating part of the chapter of history. So put it in the philosophy class. Put it in the religion class. Put it in the history of science class. But because science is a philosophy of discovery, it has no place in the science classroom. And that was my only argument. It simply doesn't belong in the science classroom because it's not science. And that essay has been heavily downloaded. I don't know what people are doing with it, but I'm happy to have served in that capacity, to at least put it in context, so that people, if you engage in the conversation, you can do it in an informed way and not in some kind of a, emotionally driven, irrational way. In a similar case, which came after this book, just a month ago, mid-December, do you remember this case? There's a Jersey kid who taped his history teacher telling the students that they'll burn in hell if they don't accept Jesus as their savior. And he said that the Big Bang and evolution is not scientific and that Noah's Ark carried dinosaurs. And and once again, plenty of people arguing that out. And I said, let me stay away from that. But then I said, no, I got to come back, all right? I'll tell you why I came back. It was being argued on the, First Amendment, separation of church and state. People said this is a violation of separation of church and state, and it can't happen, and it's public tax money, and there was a whole amendment conversation going on about why this should not have happened. And I'm thinking, no, wait, no, stop. And I said, it's got nothing to do with the First Amendment. It's got nothing to do with legalities, the ACLU. It's got nothing to do with any of these people. What it has to do with, so it's not the separation of church and state. It's that if he says the Big Bang and evolution are not scientific and that Noah's Ark carried dinosaurs, what's really going on here is that it's not that you want to separate church and state, it's that you want to separate ignorant, scientifically illiterate people from the ranks of teachers. That's what you need to do in that case. Now, if he had only said, Jesus is your savior and you got to take him and he's your, fine, okay, then it's a religion, put the religion somewhere else problem. But if he's also going to say that Noah carried dinosaurs on the ark and claim that that's true, I don't care what religion that comes from, that is demonstrably false. We know. This is the museum. We got dinosaur bones in this museum. We know where they came from. Okay? They long predate human beings. Long predate human beings. By 65 million years, perhaps. So I actually wrote that letter to the New York Times, and they published it in the letters to the editor section. I don't know if you caught it. But it was like six, I was just it was just a little thing. I had to get that off my chest, is how that happened. Now, I'm going to leave you with a thought that I hope keeps you awake at nights. And it has to do with our assessments of ourselves. There's been a long trend in the history of science to basically tell us that we are not unique in any way that one might measure that, in any sensible way one might measure that. We thought maybe Earth was something unique in the known universes. No, we're just another planet in orbit around a unique star. No, the sun is just one of 100 billion stars in a unique galaxy. No, we've got 100 billion galaxies in our unique universe. Okay, that's kind of where we are now, right? Are we sticking with one universe? Or are we going to follow in that trend and say maybe there's the multiverse? We're just one of multiple universes. We've got top people working on that one. Now, among the things we like to tell ourselves is that we are smart as a species. Smartest species there ever was. And we celebrate that fact. We say we're human and they're not. We can compose poetry. We create symphonies. Sonnets and calculus. And not all of us invent the calculus, but we at least can study it. Okay. Now, you know our closest genetic relative is what? Yeah, chimpanzee. And depending how you measure it, it's high 90s in % of DNA that we share. Now, if you ask a chimpanzee, oh, excuse me, what's the Pythagorean theorem? Chimpanzee is not going to give you the right answer there. Now, I will give you, however much time you need to teach it to him. He's not going to learn the Pythagorean theorem. Okay, let's get simple. Let's just give it the times table. It's not going to learn the times table either. Maybe up to 3. Or maybe just up to 1. Long division? No. But we can do all those things. So we're smart. Now, maybe we're not so smart. Now here's what keeps me awake at night. This is just kind of spooky. Are you ready? Okay. If the minuscule DNA difference between humans and apes, and the other apes, or in particular, the chimpanzee, if the minuscule difference in DNA between us accounts for this vast gulf in intelligence, then maybe that does not represent a vast gulf in intelligence. Consider a creature, a species, with the same increment, small increment in DNA beyond us that we are beyond the chimpanzee. Just that little bit. Give it to them. What will they be capable of? Look at what we're capable of compared with the chimp. Now ask, what would they be capable compared to us? And now think that one through. Okay? We put our toddlers in front of Sesame Street and they learn their ABCs. They put their toddlers in front of Calculus Street. And by age 4, calculus is self-evident. What do we put on our refrigerator doors? We put the pasta collages on the refrigerator doors. What would they put on their refrigerator doors? Their kids come home with symphonies composed. And so Junior just did a, 4-part harmony, 9-part symphony today. Oh, isn't that cute that Junior did that? Oh, it's so cute. Our greatest intellectual achievements would be trivial expressions of the intellect of a creature that had that small increment above us that we have above chimpanzees. They would show us to their fellow species as we show chimpanzees. They might take special interest in Stephen Hawking. They say, here's a special one among them, okay? Junior, you see, do you know the astrophysics you're doing in kindergarten? Well, in these stupid humans, he's better than us because he can do it in his head, okay? And he can do it in his head. And so they'll study him because he can do in his head what the rest of us have to write down or can't do at all. So he'd be a subject of study. And so here we are thinking we're great, thinking we're at the top of everything. It's because it feels good to cushion ourselves that way, intellectually, physically, emotionally. But the fact is, we may not be much at all. And that worries me because it might mean that there's some boundary in the universe that, in fact, we're just too stupid to figure out. Now, our advantage is every single one of us doesn't have to be completely smart because we accumulate discoveries. I don't have to invent calculus. Somebody else did. I can step on top of that and then try to increment it from there. So we're scaling this ladder rung by rung. So there may be some hope for us. But I don't want to approach this with some kind of large ego, thinking we're the top of anything. That's the source of most of the evils in the world, thinking you're at the top of something, when in fact you're not, or at least at best you're just the same. And the most profound concept that I can share with you in this book is the recognition that while it's humbling to recognize, it's humbling to see that we're not, we're small, we're kind of feeble, we're at the mercy of asteroids, but, we got 2 or 3 pounds of gray matter here that at least figured out the stuff that we did. That's kind of cool. But not only that, we know enough about the universe to know that it's not that simply we are here and the universe is out there. You look at the chemical ingredients of life itself. Put them in order, in rank order. You get hydrogen, which comes from the water molecule. You get oxygen, which comes from the water molecule. You get carbon. It's the foundation of our chemistry. You get nitrogen, in order. And the next one is the most famous element of them all. It's on every single list. It's called other. Okay, so hydrogen, oxygen, carbon, nitrogen, other. Now you go, that's in life. Now let's turn to the universe and say, hey, universe, what do you have ranked among your elements? What's number 1 for you? Hydrogen. What's number 2? Helium. Well, if you remember from chemistry class, helium is inert. You couldn't do anything with it chemically even if you tried. So let's skip that. Next in the universe, oxygen, carbon, nitrogen, other, thank you. So, we are 1 for 1 the same ingredients in the universe, which itself is a bit humbling. If we were made of an isotope of bismuth, then you'd have an argument. You say, hey, we're rare stuff. Come here, check us out. Look at where we are, all right? But no, we're made of the most common ingredients of the universe. But those ingredients are traceable to the actions of high-mass stars that forge these elements in their core, destabilized, exploded, spread their enriched ingredients, their guts, across the galaxy, creating environments where the next generation of stars will have the ingredients that can then make planets and people. And so, not only are we in this universe, the universe is in us. And I know of no more enlightening, ennobling, enriching thought than that. And that is the thought I'll leave you with this evening. Thank you for your attention. We can hang out for questions, but some people have to go, so I don't want to stop that. like if you park too far away or you like live in Jersey or something. But you can hang out. I mean, how often can you hang out? Plus, oh, and astrophysics being that 1 in a million thing. Here's the big chance. Okay, so you should wait until the microphone comes to you. Otherwise, no one in C-SPAN land will know what you asked. Okay, so why don't we come right here to the gentleman on the aisle?
Test.
Right there.
Test. You guys hear me?
Yeah, you're on. You're on. Okay, sir.
Yes, Neil. I wanted to ask when the C-SPAN program would be, but before that, I have to ask, does the Hayden Planetarium pay you enough to buy a pair of pants that isn't ripped?
Oh, the question was, is my salary sufficient to buy pants that do not rip? This rip happened 2 hours ago, and I don't normally bring spare pants to my office. That would not look good to carry extra pants into your office. And so I had to ask myself, what do I do about this fact? And then I realized it's like fashion. You know, people pay top dollar for cut-up pants. So what I did was, I swear to you, it looked too clean. I said, if it's that clean, people will think I'm just stupid and didn't like know that I had a rip in my pants. So I pulled the threads off so that it looks like they were bought this way. And now I look hit, okay? But that was not my point, okay? I meant no disrespect by wearing holy pants here tonight. It happened just a few hours ago to my dismay. You know.
Sure.
Okay. And I have no idea when they will air the C-SPAN program, but I'll give you the mantra, check your local listings, as they say. Okay, Sarah on the corner here, yes. And we'll give her a good workout.
Yeah, no.
And in fact, while I'm answering, I'll try to pick the next one so that you can stay in shape there. Yes?
Did James Cameron give you a special effects credit for the new stuff?
No, he didn't. But he did give me a free copy of the new release. That was
my actual question.
I'm a servant of public appetite. I don't look for credit.
Could anything survive a black hole? Like, would a bacteria be spaghettified? And also, would it theoretically be possible to build a spaceship that can go through a black hole? And how would that be done if you ever thought about that?
The answer to your first three questions is no. Have I thought about it? Yes. A bacterium will last much longer than you will because it's smaller, and the difference in force of gravity across a bacterium is much smaller than it would be for a human. So it would have to get much closer before it would then become spaghettified. But it is a spaghettifying machine. You won't survive it no matter what on the way to the center of the black hole. You want to take in a ship? That would be the last thing you'd ever did. And don't expect to phone home when you get to where you're going.
Wishful thinking.
No, the ship is gone. The ship shares the same space as your spaghettified atoms at the center of the black hole. So have a nice day.
I have a two-seater.
All right. Right here on the second row. In orange. Orange dude.
Thank you. You intimated at the end that when you don't know something, maybe you could speculate a little bit. I wonder if you mind speculating about black holes. A hole can be like a well with a bottom to it, or a hole may be something that goes through something, as you speculated, to maybe another universe. And you intimated that might be a small distance. So it wouldn't be at the end of our universe. It would probably be somewhere in it. How would you speculate might be within a black hole? What do you think about that possibility, or the possibilities?
Did everyone hear that question? Yeah, just question is, how can I speculate about what's going on inside a black hole? I'm going to paraphrase you a little bit. Is it a tunnel to somewhere else? Can we just dream up stuff that might happen inside of a black hole? Our laws of physics are pretty clear on this one. There's the spaghetti equation that you're spaghetti. There's no way around that. Now, it was once imagined that a black hole would be a portal to another part of the universe. And maybe you'd enter and sort of come out the other side before you hit the center. Because the real spaghettification happens if you're aiming for the center of the black hole. But Stephen Hawking just recently came out with a result that tells us that the black hole is not a portal to somewhere else because it remembers everything it ate. As you may remember, black holes evaporate. It's called Hawking radiation. It's what made him famous beyond his normal circles back in the 1970s. He recognized that the energy field, the gravity field of a black hole could could spontaneously create particles just outside the event horizon. This is the boundary between the point of no return and the point of return. It could spontaneously create particles there that would escape. And so these are particles hewn forth from the energy field of its gravity. What Hawking showed is that if I drop you in and we take an inventory of all the atoms that went in from your body, all the quarks, protons, electrons, let's inventory it. And then I wait 100 billion years and I look at the slow evaporation that comes out, I will reconstruct the entire inventory of particles that went in, body and soul, when they first, 100 billion years earlier. So the gravity field remembers the property of the matter that went in. And for that to be true, it means the information was not lost. It means the information didn't go somewhere else and leave town and show up on the other side of the universe. And while this was disturbing to science fiction writers, because they needed this as a vehicle to get around the galaxy, especially before the TV commercial ends, to get across the galaxy would otherwise take you 100,000 years. Star Trek would be boring Trek, you know, without the warp drives. But I celebrated it as this amazing, spooky thing that black holes remember what they eat, even through the slow process of Hawking evaporation. If a black hole eats, it's going to get bigger. But if there's nothing around for it to eat, it'll just kind of hang there, and then it'll just slowly evaporate. They evaporate very slowly by this Hawking mechanism. Most of them are eating faster than they're evaporating. Let's go right here, front row.
This is a question about intelligent design. I don't believe in it, but don't you think there's some force, like a Gaia force in the universe, that makes the different shapes of the galaxies, elliptical, etc., instead of just chaotic forms? Something going on.
She suspects that there might be something going on in the universe because the level of, I'm paraphrasing, the level of order that you see with the beautiful spiral galaxies and elliptical, there's shapes that look like something is going on there, some larger sort of cosmic force. And you must not have seen the galaxies that have collided and look like two train wrecks. You must not have seen those. Or the class of galaxy we call irregular galaxies that have no shape that you would point to. So you are pre-editing what you are pre-selecting things and say, oh, look, there's some interesting force going on there, when the rest of the universe is sitting there raggedy and you're not commenting on that. So what I'm saying is, the moment you think something's beautiful and just take another look. I remember I was there, we were coming over a bridge with a friend and he saw the sunset and the radiant rays and he said, oh, it's beautiful. God's talking to me. That's God. And I said, because it's beautiful? Is that why you say that? And he said, yeah, it's just, and I said, well, do you think about God when you get a close-up view of the underbelly of a tarantula? Are you thinking, oh, beautiful? No, you're not, right? But it's in the same universe. So if you're selective about the list you draw, then the universe can look like any philosophy you want it to look like. But once you take it all in, you realize that the universe wants to kill us. 99% of all the species that have ever lived are now extinct. Earth is not some cradle for life. It is a place that wants to kill us. Viruses, asteroids, earthquakes, tsunamis, volcanoes. And so we're running away from these things, and we find a little place that we think is safe, then the flood comes. And then, okay, now we finally got a place, now the temperature drops, we got to, like, put on clothing and get heat, and isn't Earth so beautiful for us? It's like, no. So I would just be cautious about that. I understand the urge, but I understand, and on top of that, there are forces that make things round in the universe. In fact, I invite you, I didn't make it to this book. As much as I liked the essay, it actually didn't make the cut to this. I wrote an essay called On Being Round. And I talk about spiral galaxies and elliptical galaxies in it. So you just Google Tyson on being round, it'll take you right there. There's a whole conversation of why things are round in the universe. And yes, it is a force, but it's not some mysterious Gaia thing we don't understand. We understand it. It is real, and we can calculate it.
But there are certain laws of physics that the universe follows.
I would rather reword that statement to say there are laws of physics that describe the universe, because the universe could care less about what we think of it. The universe is not obeying our laws of physics. So, but yes, that's correct. There are laws of physics. So there are people who say that the laws of physics is the expression of God. And if you want to say that, nothing I can, fine. In fact, that's very close to Spinoza's God. Spinoza's God was whatever you find to be the order of the universe, that is the expression of God. And that's a very different God from the God who's listening to prayers and that sort of thing, or, you know, or who puts dinosaurs on arks. These are different kinds of gods, okay? And so that would be closer to Spinoza's God. But be cautious there, because in the days when no one understood what was going on in the heavens, that was used as evidence that it was the handiwork of God, because why would you ever understand God, what God did? The fact that you didn't understand it was the citation of God at work. So now to say, we do understand it, there are laws, and also claim that that is the handiwork of God, that is riding both sides of that horse. And so I don't have a problem with it, but one needs to be aware of this philosophical trend where God is what you don't know and God is what you do know, so God is everything. And if that, then I'd ask, is fine, but is that going to help me make my next scientific discovery? If not, I'm going to put it over here and bring in the books that will. Why don't you pick now? Because that way you can run around.
All right, we're going to take just about 2 more because we're really out of time.
But there are like 10 kids in this room. I want to get a kid question.
But yes, so let's see, kid. Here, okay.
How long ago was the Big Bang?
How long ago was the Big Bang? By the way, how old are you, by the way? You're 8 years old. Thank you. How long ago was the Big Bang? We looked at how fast the universe is expanding, and then we said, okay, let's turn the clock backwards. And we watched the universe collapse back, and when you do that, you find out that the whole universe was in the same place at the same time 14 billion years ago. So that's how long ago it was, long before the beginning of Earth and our solar system and our galaxy. So we're kind of Johnny-come-latelys on this. Got another kid question right here.
Yes.
Exactly how are, well, not exactly, well, how are black holes formed?
How are black holes formed? Excellent question. We have no idea how you make the big ones in the centers of galaxies. So we've got top people working on that one. But the ones that are just kind of laying around the neighborhood, those are the remnants of the death of high-mass stars. Some of the stars that explode to spread their guts, supernovas, they will leave behind their, well, that looked bad. They will leave behind, they'll leave to the side, in some cases, a neutron star, a star packed of neutrons, but if it has more mass than a particular threshold, that will further collapse to a black hole. Yes, collapse time and space, yes. And if that star, that now black hole, is not near another star, you could accidentally step in it and not know that it was there, unless you look carefully at what it did to the light from stars behind it, because it distorts the fabric of space and time. And you start seeing weird patterns of the light behind it, as though you dragged a lens across a funhouse lens across the field of view. So you need special funhouse lens watchers on spaceships, okay? Because if you don't catch this early enough, it would be worse than not catching the iceberg on the Titanic, okay? But sometimes they're near other stars, and then you can see the secondary star getting dined upon. And then you know to sort of step around that situation. Uh-oh, I heard someone say, asteroid. Is there an asteroid in the house? Are you just worried? You just don't want to go extinct. That's your problem here? Okay, there is an asteroid discovered 3rd week of December, 2004. Okay, right. So it was discovered, and they looked for data from before and after. They got enough data to then calculate. This just took about a week to calculate that this asteroid will come extremely close to Earth. Extremely close. So, we're saying when? We got some really impatient people here who want to like go for the hills when this thing happens. So, here goes, right? So they named it. Once they saw where it was headed, they named it. They called it Apophis, after the Egyptian god of death and darkness. We did not name that one Bambi. So, it is the size of the Rose Bowl. So take a rock, fill the entire volume of the Rose Bowl with it. That's how big this thing is. It is hurtling through space. Depending on the angle you look at it, 10, 15 miles per second is its speed relative to us. Then, they figured out, well, how close is it going to get? They run it through the computer. They find out that on Friday the 13th, in April, in the year 2029, Apophis will come close enough to Earth to dip below our orbiting communication satellites. It will be the biggest, closest thing ever observed in cultural history. Now, if you want to observe that, you go to Northern Europe, get your hotel rooms now, and that puppy will go straight on by. Now, that's just the entertaining part. It turns out the orbit is uncertain enough such that we can't tell you exactly how close. We know it's closer than the orbiting satellites. But within that uncertainty, we can't tell you. We don't know it yet. Because this thing is tumbling through space. It's hard to get the exact orbital parameters. But there is a window of orbits within the total range it can have, which if it goes through that keyhole, the gravity of Earth is just right. Or rather, just wrong. So that 7 years later, once again on April 15th, not tax day, April 13th, it will hit Earth if it goes through that keyhole. It will hit Earth. And if it goes to the center of the keyhole, we know where it's going to hit on Earth. 500 kilometers west of Santa Monica. It will plunge into the Pacific Ocean, go down a depth of about 3 miles, and then explode, cavitating the Pacific. I've got to watch my pant ripping there. Cavitate the Pacific to make a hole 3 miles wide and 3 miles deep. Oceans don't like having holes in them, okay? So the act of making this hole sends a first pulse all across the Pacific. And there it is in motion. Then the walls collapse down in. It sloshes back into itself, rises high into the atmosphere, and comes back down, cavitating the ocean again. And this rhythm will repeat dozens of times. And each time this repeats, a pulse, a tsunami wave heads towards the shores. Now, unlike the Indonesian tsunami, by the way, you didn't hear about Apophis when it was discovered because its orbit was calculated the same week as the Indonesian tsunami. That's why you didn't hear about this. We knew all of this for 2 years now. We knew it. But justifiably, it was put in the back behind the Indonesian tsunami, but this tsunami make the Indonesian tsunami look like somebody just stepped into a puddle. Unlike the Indonesian tsunami, which just went smoothly onto the shores, unrelentingly, this tsunami will come to the shores but then cycle back to get ready for the next pulse. And again, and again. So what will happen is the tsunami comes to the shoreline, it grabs the homes that were there, and then pulls it out, okay? Then, time to go back to shore. And so now it comes back. Now the house has a different shape, okay? The house is no longer a box. It is a tangled mass of construction materials. And so now it comes back, and it churns away all evidence of civilization on the entire west coast of the United States. Basically sandblasting it clean of all traces of civilization. How about 50 feet high? So 5 stories high. Now, there will be stupid people like surfers who want to say, let me get that wave coming in. There will be stupid meteorologists. Here comes the wave right here. Get the camera right here. Can you see that? You know these people exist, right? The hurricane's coming down on the Florida coast, and they got somebody there, you know, and meanwhile, the cameraman's just trying to back up, you know, away from the thing, while the reporter's reporting on the waves that are crashing on the shore. You know there'll be people who want to do this, but in principle, nobody has to die because we can predict when this will happen. Now, better than predicting when it will happen and telling everyone, run for the hills, I'd rather actually do something about it in the first place, like deflect it. Hey, what an idea. And we got top people working on this one. You take a spaceship, bring it, if this is the asteroid, and bring it up next to the asteroid. Here's a spaceship. And then it'll want to fall towards it. They have mutual gravity. But you put in little retro rockets to prevent it from falling in. If you do this early enough, you can actually gravitationally tug the asteroid out of harm's way. Because the act of preventing the spaceship from falling is tantamount to pulling the asteroid in your direction. And all you have to do is pull it out of the keyhole. It'll still come by, and you'll still have to keep an eye on it later on. But if it's out of the keyhole, we're safe. Which brings up a whole other set of problems. Suppose you try to get it out of the keyhole and you miss, and then it goes to a different part of the keyhole, and then lands and hits another country. Had you never touched it, insurance forms would have called that an act of God. But now that you touched it, what do you call it? What is that? It's an act of war, right? So this, you know, this is an unresolved political, cultural problem. And suppose it's headed for the Indian Ocean. Obviously, we're going to want to care about it if it's headed for the Pacific, because we're directly affected by it, with the most expensive real estate facing the tsunamis. But suppose it's somewhere else. Who pays for it? There's no mechanism that exists right now to resolve how to handle that problem. There's no international mechanism. But we've got people working on it. One of them is a friend and colleague, Rusty Schweiker, who's got a website, the B612 Foundation. Just check it out, .org. The numeral 6, numeral 1, numeral 2. That happens to be the name of what? That is the asteroid that the Little Prince landed on. Oh, isn't that cute? Isn't that cute? The asteroid will make us extinct, so it's not that cute. So anyhow, we would survive. That's not a species extincting asteroid. Apophis is not. It would just do a lot of property damage. And so even if it did hit. But it would be a bad day on Earth and be the worst natural disaster ever. But again, nobody has to die. And so now I just totally bummed you out, you know. But anyhow, the universe is a fun place, and thank you for all just coming to hear me talk about. By the way, I just learned. I just learned like a couple of days ago that this coming weekend, this just eked onto the New York Times bestseller list. I didn't know. Now, I don't know how long it'll stay there. You know, who knows if a next Harry Potter book will come in and bump it out. Who knows? But it's that one way, and I've never been there before. It's a very good feeling, and it's only there because of support from you guys and others of your passion for hearing about what we do as astrophysicists. Thank you for coming. I'll be outside to sign books. Thank you.
Neil deGrasse Tyson is author of Origins, 14 Billion Years of Cosmic Evolution. The Sky is Not the Limit, Adventures of an Urban Astrophysicist, and his latest, Death by Black Hole and Other Cosmic Quandaries. Director of the Hayden Planetarium at the American Museum of Natural History, you can learn more about Neil deGrasse Tyson at amnh.org.
It's coming to your senses. Another one, the knowledge of nature. I'll talk about the vagabonds of the solar system. In there's like Pluto shows up, but I'm done with Pluto, okay? So let's leave Pluto alone for a night. I think it's got to get over having been Plutoed. That was the word of the year. Did you see that? To be Plutoed? Plutoed. So was Pluto Plutoed? Or was Pluto something else which had to happen, and then everything else is Plutoed thereafter? We got to get top linguist on this, all right? Get a full report on that in the morning. So we'll slip by that one. I'm okay. You're okay with that? I'm okay with that. I got one here, Goldilocks. Here we are in section 4, the meaning of life, the challenges and triumphs of knowing how we got here. We've got a chapter called Goldilocks and the Three Planets. You remember Goldilocks. We all know Goldilocks. Yeah, we all know Goldilocks. You know Goldilocks. Goldilocks. Now, here's my problem with the Goldilocks story, okay? I got a problem. Because if I were the Bears and I found Goldilocks in the house, I just eat Goldilocks, okay? That's what would happen, right? That'd be the end of the story, and the lesson is don't go busting into other people's houses, okay? You want a lesson, there's a lesson, all right? But they want their lesson to be a little more nuanced. So, one porridge is too hot, the other's too cold, one is just right. Well, in the solar system, you can be a distance from the host star that might be too close for water to be sustained as a liquid. If so, all the water on your planet will evaporate, not available to you to make life, because life as we know it requires liquid water. So now if you can go a little farther away, whatever water you might have, you're too far from the sun, the intensity of the sun's energy is too low, the water freezes. Once again, not available for your circulatory system. And so you imagine that beyond a certain distance, you would not find planets with water, nor then planets with life. So there'd be this comfortable Goldilocks zone, the habitable zone, where you'd find liquid water prevalent on the surface of a planet. Fine. Fine. Turns out you can go outside the zone and find water, but I'll get to that later. But right now, let's just consider that scenario. Now, turns out other things affect this, like greenhouse gases that trap heat and air pressure, where if the pressure's too low, you can't have liquid water. The water just goes straight from ice to gas. You've seen this before. It happens with dry ice. Do they still have the ice cream man in the park and he opens up the thing and there's dry ice and it's frozen carbon dioxide? You've never seen liquid carbon dioxide because the air pressure on Earth is too low for it to ever reach a liquid. It goes straight from solid to gas. We have a word for that. It's called sublime. I kind of like that word, sublime, for such an odd chemical phenomenon. And so fine. So we're here on Earth and say, we're fine. We've got room temperature. I'm good with that. And then you look a little to the left, you get Venus, our sister planet. It's about the same size as we are, about the same mass as we are. A lot of the same structural features that we have. And it's just a little closer to the sun than we are. If we are 1 unit of distance from the sun, Venus is 0.7. So Venus is 70% of the way to us from the sun. So you say, okay, Venus, are you just like Earth? No. Venus, its atmosphere is nearly 100 times as thick as our atmosphere. That's bad enough, because you'll just get crushed. But you'd be lucky if that's all that happened to you, because the temperature on Venus, it having a carbon dioxide atmosphere, it has a runaway greenhouse effect. It is 900 degrees Fahrenheit on the surface of Venus. 900 degrees. And I did the math. You could take a 16-inch pizza, put it out on the windowsill, and it will cook in 9 seconds. You would have been vaporized in the process, but you'll have a cooked pizza that's just right in 9 seconds, okay? Now, of course, Venus is the goddess of love and beauty, and it's 900 degrees. They didn't know that when they named the planet. Now let's go a little to the right. A little bit farther from the sun than we are. We get planet Mars. Mars has riverbeds that meander, floodplains, river deltas, lake beds, but not a single drop of water at all. But these features were made by water. We are 99% confident of that assertion. That's what water does when it flows in abundance. It makes rivers and lakes and valleys and river deltas. You could do a comparative geography of Earth features and Mars features, and one for one, you nail all of them. Where'd the water go? Nobody knows. We think it sunk down below the surface, froze there in a kind of permafrost situation, but there's none on the surface. Some knobs got turned on Venus and on Mars to turn them into what we would consider completely inhospitable environments. Venus is 900 degrees Fahrenheit, Mars is 250 degrees below zero. Bone dry. Mars, it's right there. It's right there. Do you know Mars, among all the planets, is the most hospitable place there is after Earth? Yet it'll kill you post-haste. So the lesson there, for me, is we know Mars once had water and it does not. Why not? Let's find out why. Because if we find out which knob had turned in the ecosystem of Mars, I want to know if we're turning that same knob here on Earth. We don't know that. You got people say, why are we studying the universe? We don't need, what if we worry about Earth problems here? And I'm thinking, well, how about that asteroid coming in? You're not looking up for that one. You worried about the budget and Congress and this? We got an asteroid coming. We got a planet that has a runaway greenhouse, a planet that used to have water and does not. Excuse me. Where do you think answers are going to come from? We're not an island. They come from the sky. Thank you. Answers are going to come from the sky. We're not some...
20 years ago this week, astronomers witnessed one of the brightest stellar explosions in more than 400 years, a supernova that blazed with a power of 100 million suns. Next on Book TV, astrophysicist Neil deGrasse Tyson. His new collection is Death by Black Hole and Other Cosmic Quandaries. This talk from the Hayden Planetarium at the American Museum of Natural History in New York City is about an hour 45 minutes.
Good evening. It's quite a wonderful showing for this night. So you might be wondering, who is this strange man standing in front of you? And I mean, you know, I look exactly like Neil, and so I might just introduce myself as Neil deGrasse Tyson. No, actually, I am here to introduce him. He's an old friend of mine, and I'm very happy to have this pleasure and honor to introduce this great man who is about to show up here. And my name is Ben Oppenheimer. I'm one of the astrophysicists here at the museum. But I thought about, well, how do you introduce a man like this? Everybody has some notion of who he is. Otherwise, we wouldn't have this a showing like this in the audience. So I thought I could go through all the ridiculous things he's done in his life, like going to a substandard school up in Boston, up in Cambridge, something called Harvard, I think it was. I don't know these things. But he did decide ultimately to go to Columbia for his PhD, which was a magnificent decision. And in fact, that's where I met him 17 years ago when I was an undergraduate and he was a graduate student. And I thought, wow, this guy is really dynamic, but he's kind of a slacker. And you know, I wonder what he's going to end up doing. And we used to joke around a lot. It invariably led to my being punched in the stomach at some point. And if I run out of here later, it's because I'm avoiding another one of those punches, so please excuse me. But then over the years, I went off to graduate school in California. We lost touch for a while, got back in touch around 1999. And I heard that he was putting together this magnificent new planetarium, rebuilding the Hayden, which I had grown up going to, of course. And he showed me around before it opened, and there was this certain glee in his eye, just utter pleasure and excitement of walking around, seeing these new exhibits, explaining some very complicated ideas in modern astrophysics in a way that hadn't been done before. And I could tell his passion was there. This was no slacker at all, and you can go and look up all of his various accomplishments. There are many, but I'll tell you this, I know of nobody, any colleague or any even acquaintance who has a dedication and interest and passion for educating the public about what we do in astrophysics other than Neil Tyson. And he's got a way of saying things that I hope you enjoy this evening. So without further ado, I will introduce my great friend and colleague, Neil deGrasse Tyson.
Thank you all for coming out this evening. I'm just told that there's a foot of snow that just fell, so we're stuck here all night. Most of the time that I'm called upon to speak to the press, it's because there's some cosmic thing that happened. The universe flinched. And here at the American Museum of Natural History, we're not far from the major news centers of the nation. ABC, CBS, NBC, CNN is now just down the block. And so I'm actually a little uncomfortable being in the media for something that is a fully just sort of marketed thing, all right? I'm in the media now because there are marketing people that put my face in front of the camera to sell this book. For those on the TV screen. If you might not have known, we are being taped for later air on C-SPAN this evening. So whatever you say can and will be held against you. I guess my point is, I would say 85% of the time I get approached by the press, it is because I didn't twist their arm. They wanted a comment on something that happened in the universe. And that level of public curiosity and appetite for the cosmos, I don't take lightly, neither do any of my colleagues. We see it as a genuine measure of the public's fascination and appreciation for all we do in the professional astrophysics community. And in case you want to know how many of us there are, there's about 6,500, 6,500 astrophysicists in the world. And if you remember your population numbers for the world, that number is about 6.5 billion. So you divide those two numbers, you get 1 in a million. So here's the catch. If you're ever in the company of an astrophysicist, that's the time to ask your questions. Because you never know when the next time will be where you'll be around another astrophysicist, okay? But it's not that many people who are responsible for bringing all these riches of the universe to you. And we are tickled to death every time the public shows interest. If not for the Hubble telescope, for discovery of a black hole in the center of the galaxy, right on down to the discoveries of the space program. So I want to publicly thank all of you and the rest of what makes up the general public for your support for what we do over all these years and what I expect to continue into the future. I want to make sure there's plenty of time for Q&A at the end. It's my favorite part of a program. And I'm not going to read from the book, because you can just buy the book and read the book. You don't need me to do that. So what I want to do is first tell you about it, and then sort of pluck subjects from it, and then reflect on those subjects. And I'll do that for most of the hour, and then we'll break and take Q&A. That's the layout for the evening. The book is called Death by Black Hole. Of course, I was told that C-SPAN has that one camera, and so you put this here, then it's just always in view, of the camera. I learned that from Andy Rooney some years back. He just took his book and just put it there and went and had a cup of coffee, and they had to keep showing it, I started writing for Natural History magazine as a columnist in 1995. The then editor had heard me on the radio and felt that they needed some contributions from the universe to bookend the magazine with the contribution that they were getting monthly from Stephen Jay Gould. And so I said, sure, sounds like fun. And so I began in January 1995, not knowing that every mushroom had this mystical fascination with the numeral 7, the number 7. And so when he went to label the colors of the spectrum and got 6, he said, we need 7 somewhere in there. So there's indigo. You got it, we're stuck with indigo. Now, if you have enough precision to put in indigo, the 10 other colors we could have given you in this full continuum of this spectral light. Any color-sensitive people could rattle off 30 colors in there. But no, we got 7, and Roy G. Biv was born. Okay. If you go beyond the V, beyond V, you get what? Ultraviolet. We have no way to detect ultraviolet. Actually, that's not completely true. You can detect it in a time delay sense. Okay? So, depending on what shade of skin color you have, you go out to the beach and lay under the sun. If you are not protected, you're laying there, that's fine, and then how many hours later you look like a lobster? Okay, so there's a delay there. It's the ultraviolet that made you look like a lobster, but you didn't know it at the time. At the time. So by the time you figured it out, it was too late. Let's go to the other side of red. You get infrared. Can't see that either. We do have infrared sensors. We sense infrared in the form of heat. That's what we call heat when we feel infrared. But beyond infrared, there's microwaves. We have no microwave detectors. Well, now we do because we all carry around cell phones. These are microwave detectors. But if our eyes were sensitive to microwaves, tune in the microwaves, all your cell phones would be ablaze with light. Okay? We'd all be walking down the street, you know, and you'd know who had a phone call and who didn't. Okay? If we had microwave detectors, the microwave towers would be ablaze in broad daylight and in the middle of the night. We have no such detectors. Radio waves, we can't detect radio waves. X-rays, gamma rays. This is the full sweep of the electromagnetic spectrum. And in astrophysics, we have telescopes and detectors in each one of these bands, far beyond what your naked eye can detect. And so every day, every night of every day, the astrophysicist is invoking a full suite of senses that brings us that much closer to the universe. Because if you only observe the night sky with a visible light telescope, expressions of our own eyeballs, you'd be missing what black holes are doing in their environment. They're dining, they're flaying stars, the outer gas layers of stars as it descends, spirals and descends down to this abyss. It radiates ultraviolet and X-rays. So the first X-ray telescope, the first thing it discovered in the universe was a black hole candidate. SCO X1, Scorpius X1. Then there was another one in the constellation Cygnus called Cygnus X1. These were sources of X-rays we were previously blind to. Turns out, black hole, right there. Black hole. So you can't claim to know the universe unless you look in as many different ways and invoke as many different senses as you possibly can. Now, there's a point to all of this. The point is, until about the turn of the century, not our century, but the 1800s to the 1900s, until then, it was possible to say, to do an experiment and say to yourself, that makes sense, or that doesn't make sense, and you had a good chance of being accurate in your assessment. Come the 20th century, where telescopes started getting seriously big, where atom smashers started breaking apart atoms, probing nature on levels and on scales never previously accessible to our senses. Now, what does it mean for something to make sense? For something to make sense, what that means is, if I take this bottle of water and I let go of it, what will happen to it? It will fall. In fact, so linked is my act of letting go to the fact of this falling in our minds that all you have to do is say to me, drop it. And that means let go. But suppose you lived in a world where 30% of the time, when you let go, this went and floated to the ceiling. 30% of the time. And so only 70% of the time it fell. Well, then common sense would mean something different under those conditions. What was common is 30% of the time the thing floats up. So the word drop wouldn't even exist. Oh. Someone gasped over in the corner here. It would be, let go and let's see what happens. You know, people be taking bets. You know, people bet on all kinds of things. So what happens is we break the atom, get inside, get into the nucleus, and a whole new world of physics opens up to us. The world of quantum mechanics, where the laws are different. Edwin Hubble discovers that our galaxy is not alone among galaxies in the universe. A great discovery of the 1920s going on simultaneously while quantum mechanics was being discovered, the science of the small. And not only that, he discovers that the galaxies are hurling away from each other. He discovers the expanding universe. A few years later, the Big Bang theory of the universe advances, with not much data, but that we're expanding at the time. You turn the clock back, you find that the whole universe, sometime in the past, all occupied the same volume at the same time. And you say, that doesn't make sense. How could the whole universe fit on the head of a pin? That doesn't make sense. And then you realize the universe doesn't care about your senses because we're probing it beyond the range that your senses were formulated. Our senses emerge from being born an ordinary human being in this world, breathing air, walking in 1 G's worth of gravity. That is our life. And so in modern science, we no longer require that a successful idea make sense. And I think that's created quite a bit of confusion when a scientist says, oh, well, the whole universe was this, and a particle pops out of existence here and shows up there, and there's 11 dimensions, and this, and you hear this say, what's he smoking? You know? You wonder what's going on with the scientists today. And the fact is, our regime is no longer grounded in the limitations of the 5 senses we carry with us. And so the lesson there, and what comes across in that chapter, is my goal, is that before you celebrate the brilliance of our 5 senses, think about what it is you're not seeing about the universe, and then ask yourself, what do you need to know about that in order to claim that you know the universe to begin with? And that's island. We are a participant in the cosmos, vulnerable to cosmic phenomena. Not only that, there's cosmic phenomena that would give us insight into who and what we are. And if we don't have that urge, you just move back into the cave. Because that's where we'd all be if we didn't have some fraction of us out there trying to push that frontier. It wouldn't have to be a cosmic frontier, just any frontier. Well, I wonder what's on the other side of the cliff. That person doesn't come back, so that's fine. What's on the other side of the valley? It's a cliff. I meant to say mountain there. I'm sorry. I didn't mean the other side of the cliff. Let's start that again. So they said, what's on the other side of the mountain? And so they go and find out, and they bring back fruits or riches or whatever. Whatever. That's what exploration is. That's what it is to be human. That's why we have a space program. That's why we have the luxury of having a space program. So I don't know. The universe, I see that's the ticket right there. It's where our insights will come about where we fit in this universe. I'm going to go on to a radio bubble. It's part of the section on the meaning of life. A radio bubble, you might have not heard that phrase before. I don't know. A radio bubble. A radio bubble, you might say, if there are aliens out there that are intelligent, how would you tell them that you're here? Do you send a spaceship? Our fastest spaceships ever launched would take 50,000 years to reach the nearest star. That's slow. And there's a rule in science. If you do an experiment, you want to be alive when the experiment is done. They don't tell you that in graduate school, but you figure that out empirically, okay? So, sending a probe to another planet, I don't think so. Not unless we develop warp drives or something, okay? And that could happen, but I don't think anytime soon, or anytime that we should be banking on. So, what do? Well, you can send light. How about radio waves? That's light, a form of light, radio waves. We have big radio telescopes, just reverse them, send us a signal out the other way. It will travel at the speed of light, 186,000 miles per second. Still takes a while. There's nothing close out there, nothing. The nearest star to the sun is 4 years away, traveling at the speed of light. So it still takes a while, but you can outlive that one, all right? So you do this, And you say, well, wait a minute, maybe we have a head start on this plan. Let's look back in time. How long have we been radio loud? How long have we been producing radio signals on Earth, some of which will have leaked away from Earth? You just go back in time. Turns out TV waves, the frequency that we use to communicate with television, those go straight. If they don't hit you, they're gone. They leave the atmosphere. That's why you don't, like in the old days, remember when TVs had antennae? Remember that? Yeah, you're all 20 and under, I know, right? There was a day long ago where you had to get out of your sofa to change the channel of the television set. And while you did that, you had to adjust the antenna until it was just right, but then you'd be in the way of the screen. Then you'd let go, and then the image would go bad again. So everyone would then tell you to stand there holding the antenna. This was many moons ago. People used to live this way. It's true. I'm making it. I'm just thinking, people they could sit in the couch, honey, where's the remote? You know, and like spend 10 minutes looking for the remote rather than just going up to the TV to change the channel. Anyhow, back when TV was broadcast, which it still is, but a lot of people get it via cable today, TV waves would go straight out. And so too would shortwave radio would go, well, it depends on which wavelength you use. Some would reflect off the ionosphere of the Earth and stay sort of trapped. Others would escape. But if you take the inventory of what these programs were, you can say, hey, we have this growing sphere of influence in the galaxy, beginning with our earliest broadcast. They've been going now for 70 years. So, in fact, we are in the middle of our own radio bubble that has a radius of 70 light years. It's a radius that has washed over all the stars that fill that volume. Hundreds of stars. And so we've already announced ourselves to aliens, if they're there and want to listen. So the earliest of these programs, it would be, so the aliens would listen in, right? They get the feeble signal, but they're smart aliens, so they can figure it out, recode the carrier signal to the main thing, and get the image, and there's howdy doody, okay? And then they see, well, this is an interesting species. Let me figure out how the male and the female interact with one another. And they learn that from early episodes of I Love Lucy. Yes, these are benchmark ways that men and women interact. And then as the radio wave continues to wash over, then they have episodes of Gomer Pyle. You know, and you think about this, this is our first introduction to the aliens. This is kind of scary. Now, there's some programs that they would never get, programs that have only ever been broadcast over cable, like MTV's Beavis and Butthead, okay? So there's certain things that are good that's not the first thing the aliens get. So some programming is forever hidden in the electrons of your coaxial cable. So you look at this and you say, what will they think of us? You know, and then they get broadcast that there was like atomic bomb and 100,000 war, and I am certain that these aliens who are in desperate search themselves for intelligent life in the universe, they will conclude that Earth does not contain intelligent life and pass us by. How am I doing on time here? Are we okay? I got a few more things to talk. Are we okay? Like, you cool? Anybody got like be somewhere after this? I just want to make sure that we're okay. I don't want to mess up your plans for later. Where are we going? So, when the universe turns bad. Ooh. Well, that contains the title chapter. Writing an essay, at least for me, would be like giving birth. Now, the women are saying, you have no clue what giving birth is. Okay, I confess, I have no clue. about giving birth. However, each of these essays is sort of the sum, each essay that forms a chapter in this book, 12 years, hand-picked essays that have appeared in Natural History magazine, selected and culled and organized for this volume. Each month that I wrote an essay, it was the sum of what I knew in astrophysics, all that I knew as an educator, and all that I could bring together to make it real. And to pump that out each month, it was like my flesh was getting hewn from my body and put down onto the page. And I felt like after each month I had to regrow part of my body cells. Okay, that's why all I can think of is like it was giving birth. And so no, it's not easy to do that, it's hard to do that, but it is one of the greatest pleasures of my life because I get to think about what words to use, what phrases, what words work together, either poetically, scientifically, rhythmically. And so it's my hope that you could pick up this book, open to any page, and land on a paragraph in that page, and you'll feel good reading that paragraph. Okay? That's my goal. Now, whether I achieve that goal, I don't know, but that's the goal. And so these chapters are some of what I feel were my best, as well as chapters that I didn't necessarily feel were my best, but were highly requested on my website and by other means of communication, highly requested by the public. So we're organized in sections, and I'm just going to pluck something from each section. First section, the nature of knowledge. Later on, there's a part, my favorite section is when the universe turns bad. All the ways the cosmos wants to kill us. And in there is the title chapter, Death by Black Hole. But there's also a chapter on killer asteroids and a full discussion of one that's actually headed our way. If we have time, I'll get to that. Just remind me if we can fit that in. But just if there's time, I don't want, just if it fits in the session that we have together, remind me to tell you about the asteroid that will render the entire west coast of the United States unlivable. So let me lead off. There's a section here called The Nature of Knowledge. And there's an essay there that was smooth, right? That worked. That one worked. Hardly ever works, but it worked now. We'll do anything for C-SPAN here. There's a chapter called Coming to Your Senses. And I want to just sort of share with you where I'm trying to go there. We all know the human body has senses. How many? 5. Some people claim they have a 6th sense. We'll get to that in a moment. But the 5 we know and love, sight, hearing, touch, taste, and smell. Thank you. Now, a couple of these are not very useful when you're studying the universe, like taste. Your tongue doesn't reach the cosmos. So the tongue is not very useful. Neither is your sense of touch. But sight is certainly very useful. No doubt about it. And excuse me, I'm nursing a chest cold from a few weeks ago, so forgive me. We got our 5 senses. And then there's some people who say they have a 6th sense. They can know things that your 5 senses can't. And you say, well, what might that be? They can maybe feel like they know the future, or they know when someone's looking at them, or they feel it somehow. Turns out, anytime you bring that person into a controlled laboratory, those talents just go away. They just don't exist. They're missing in the laboratory. So either it is an actual talent that just somehow hates laboratories, or there's sort of a delusional thing where you think you have the power, but in fact you don't, and you're remembering the hits and not the misses. Like you pick up the phone, you say, Grandma, I knew that was going to be you. Okay? Well, if it wasn't her, you wouldn't say, oh, I thought this was going to be my grandma. You just don't even say that, because you kind of look bad. And so you forget the misses, you remember the hits, and there's this self-selection going. Psychologists have known about this forever. We dupe ourselves into thinking we are more powerful and more brilliant and deeper and more insightful than we actually are. Maybe it's an ego-preserving feature of what it is to be human. But by the time our session together is over, I hope to disavow you of those great feelings you might have of ourselves as a species. So it turns out in science, we have dozens of senses. There's plenty of things you might want to know about, but you can't because you're limited to your 5 senses. For example, right now you have no clue and no way to measure without a device what is the level of the magnetic field in this room. No clue. If you could measure magnetic field, you could think of that as another sense. Measure the magnetic fields around you. We have no idea. We are not equipped for that. Neither can we measure, for example, the presence of ionizing radiation. Well, you would eventually know this because, like, your limbs would fall off and you say, hey, something happened. Okay? You'd be sterile. Well, that'd take a little longer to figure out. We have no capacity to measure this. Other things. You don't know, there's some obscure things like polarization. You can't detect the polarization of light. And that light vibrates in 2 different directions. And you can polarize it so it only vibrates in one direction. You can devise glasses that can polarize light. But you still wouldn't know the difference. You don't know. It's a big deal in astrophysics, whether light is polarized or not. That tells us where light is coming from and what its points of origins are. But another sort of everyday thing you just can't figure out, one of them is you can't detect low-level earth tremors. Why? Because you have, like, shock absorbers in your knees. And so your knees sort of get rid of it. You have filters against it, but you put up a seismograph, there it is. There it is. So I can go on and on and on and on and on. Perhaps the most important sense we don't have is the ability to see outside of the spectrum of visible light. You know visible light, Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. It's a Biv there, B-I-V. Now, where'd the indigo come from? Isaac Newton, who first labeled the colors of the spectrum,